Hi guys, this is Rena Lee from Peer Tutoring Club at DIS. Today we're going to start off our new section 1-2, which is properties of limits. Properties of limits. So let b and c be real numbers, let n be a positive integer, and let f and g be functions with the following limits. So limits of fx will be L, and limits of gx will be K. The first thing that we're gonna learn about properties of limits is scalar multiple. You guys don't have to memorize these names, but make sure you memorize all the properties and how to solve them and what they are. For scalar multiple, if the limit is multiplying with a number and a function like this, then this equals a number multiplying with the limits of the function, and with this equals eventually to k times L. The second, sum or difference. The limits of function fx plus gx equals to limits of function fx plus limits of function gx. And this eventually it equals to L plus K. For people who's confused with what is L and K, it is given that limits of xx equals to L and limits of gx equals to K. Right over here. Make sure you know the information that is given to you to solve the problem, because it is a very essential thing to know. 3. Product. Limits of function fx and gx are multiplying with each other, and this equals to limits of xx times limits of gx, which is equals to L times K. Quotient. Limits of fx over gx equals to limits of fx over limits of gx, and this equals to L over K. But the thing is, K cannot be 0. 6. Power. Limits of fx of power of nth power equals to the whole bracket of the limits of function fx nth power, and this equals to L to nth power. Composition. This one is the most important about all these properties of limits, and you will see this very frequently. It is that if limits of f and then inside fx there's gx like this, this means that there's a limit of x towards k of the function. This k came out from gx, which is limits of the function gx equals to k. So any functions like this, you have to change the limit into this. So for example, if there's a limit of x towards 2 of a function, but x equals to gx, then this equals to limits of x towards 1 of fx if limits of x towards 2 of the gx equals 1. Got it? And then the last one is the squeeze theorem. This is also known as sandwich, because as you see, the function that you want to find out about, it is in between these two other functions, so that the actual function that you're going to find is squeezed in between. So the definition of the squeeze theorem is that if gx is less or equal to fx, which is less and equal to hx for all x except possibly at x equals c, and the limits of gx equals L, which is equals to limits of hx, then at the end, limits of fx equals to L. For example, given that fx equals to sine x over x, then the closest number we know this. And then we know that by plugging in the limits of x towards infinity of the -1 over x, the value x equals to 0. And then we also know that limits of 1 over x equals to 0. Since the number that we want to find, that limits of sine x over x, we want to find this, and then this value is in between these two values, which is known as 0 and 0. By the squeeze or sandwich theorem, limits of sine x over x equals to 0. Now let's move on to the practice questions. Given that limits of fx equals 9, and then it is going towards 3, and then the limits of x towards 3 of the function gx equals to -4, and the limits of x towards 3 of the function hx equals to 0. Find the limits that exist. Pause the video and then find the answers as yourself, and then check the answer. Okay, so given that limits of fx equals 9 and the limits of gx equals -4 and limits of hx equals 0, we need these two information to find the answer for the A question. By using the properties of limits up here, we know that if there's a number in front of the function, it means we need to find the product, which is multiplication. Therefore, we know that limits of x towards 3 of this function equals limit of x towards 3 of 2fx is subtracted by limits of 6gx, which is equals to 2 times 9 minus 6 times -4, which is 18 minus -24. And then since there's negative and negative, we know that this will change into positive addition. Therefore, the answer for A is 42. B. we only need the information for the gx. By power property, since we can see 2 up here, we know that this equals to limit of 8 times gx with the whole bracket of power of 2, which is also equals 8 times negative 4, and then it is squared, which equals 32 squared. By using the calculator, find what is the answer, okay? Because this is not too hard to find by using your calculator. So I'll move on. C could be kind of tricky for you guys, so do it as your own and then find your answer later. To find your answer, you need the information for all these 3 functions. So by quotient rule, we know that this equals to limit of this and limits on the bottom too. And this plus limits of 3 times hx over limit of x plus 1. By using the information up, we know that it is also equals to and plus right here. Since this is so easy to calculate, I'll just show the procedure, not explaining, because it's just plugging in. Since this is just 0 equals to 0, we know that the whole answer is 3 over negative 4. Number 2, given the graph of y equals kx below, evaluate the following. So, for the first, we have to see which way is x going to. We know that x is going towards 3, which is over here. Therefore, we can see that limits of x towards 3 minus of kx is a little bit bigger than 1, because x towards negative 3 means that we're looking for the value here. This should be, according to the graph, this should be a little bit greater than 1. Therefore, I wrote 1 plus. And then, limits of x towards 3 plus of the function equals 1 minus. It is also because, by the same rule, we are looking for the value going this way, and then it is a little bit less than 1. And since these two are not equal, we can say the value that we want to discover over here is d and e. Because by the rule of composition, we can say x towards 1 plus of the kx is 2. However, limits of x towards 1 minus of the function is 1, as you can see in the graph. 1 plus over here is 2, and 1 minus is equals to 1, which is not equal. Therefore, we can say it is D and E. B. So, again by composition rule, we can say that limits of x towards 2 of the function equals 1 plus. We can find this in the graph again by linking it here. Since we can see that by both direction, 1 plus x going to 1 plus and going to 1 minus, actually 2 plus and 2 minus, we can see that it is always above 1 according to the graph. Therefore, limits of kx towards 2 equals 1 plus, and by this value, according to the composition rule, it should be goes into another function, which is limits of x towards 1 plus over here of the kx equals 1 plus equals 2. Therefore, the answer that we look for question B is 2. This is it for today's video. Thank you for watching, and please look over for other videos on our website. Thank you.